So let us calculate the transformation matrix. So I have written again the same equation of the motion that we have done to bring the frame n to n plus 1. So we are going to write the transformation matrix of n plus 1 with respect to n, and we will give it a short form of capital A n plus 1. And we know the first rotation with respect to z-axis, the translation in z-axis, the translation again in x-axis, and the final rotation uh, with respect to x-axis of an angle of alpha n plus 1. We have to multiply that, so we will have to write first the rotation matrix. We all know that the rotation matrix with respect to z-axis we will write as cos of angle here is theta n plus 1, then sine theta n plus 1, 0. Let me write it a little bit more clearly because I should not overlap. Okay, so theta n plus 1, 0 with a scaling factor of 0, then minus sine theta n plus 1, then cos theta n plus 1, 0 with a scaling factor of 0, 0, 0, 1, 0, and finally, since there is no translatory motion here, it is going to be 0, 0, 0, 1. So that is rotation with respect to z-axis of an angle of theta n plus 1. I already told you theta n will be positive if it is anti-clockwise. It will be negative if it is clockwise. Next is translatory. We know that always translatory, uh, sorry, we always know that in translatory motion there is no rotation part. So the rotation part will be simply uh, identity matrix with a scaling factor of zeros, whereas the linear motion will be represented by 0, 0. In the z direction it is d n plus 1, 1. And similarly here also, since it's translatory motion, 1, 0, 0, the identity matrix 0, 1, 0, 0, 0, 1 with a scaling factor of 0, a n plus 1, 0, 0, the scaling factor of 1, followed lastly by a rotation again with respect to x-axis, which we can write it as 1, 0, 0, 0, 0 cos, here the angle is alpha n plus 1, sine alpha n plus 1, 0, 0, minus sine alpha n plus 1, cos alpha n plus 1, 0. Finally, there is no rotation, there is no translatory motion, so it is 0, 0, 0, the scaling factor of 1. Now, if I multiply all of this together, I will get the transformation matrix of transforming frame f n plus 1 to frame n as, so let me write the combined one. So if I multiply it all together, I will get cos of theta n plus 1, sine of theta n plus 1, 0, 0, minus sine theta n plus 1 multiplied with cos alpha n plus 1. Similarly, cos theta n plus 1, cos multiplied with cos alpha n plus 1, sine alpha n plus 1, 0, then sine theta n plus 1 multiplied with sine alpha n plus 1 minus cos theta n plus 1, sine alpha n plus 1 cos alpha n plus 1 0, then a n plus 1 cos theta n plus 1. So this is multiplication of a n plus 1 cos of theta n plus 1. Similarly, a n plus 1 cos of, sorry, not cos, sine of theta n plus 1. Then finally d n plus 1 with the scaling factor of 1. So this is what we are having, and this can be written in short form as a n plus 1. So remember here, see, everywhere theta n plus 1, alpha n plus 1, d n plus 1, everywhere, whether it is theta, whether it is d, whether it is a, whether it is alpha, it is all having the subscript of n plus 1. That's why it is important to write a n plus 1. Okay, so if I have to move, from hand, so thus, so let me write it, thus to move from base of the robot to hand, to the hand having n joints, we need to find each of the frame and the transformation between them. Okay, so I will be writing that I want to find what is the transformation final. This is the step 3, step 3. So what is the transformation of hand with respect to the universal frame? Let us say it is U. Then I will have to find out what is the frame or transformation matrix of 1 with respect to U, what is 2 with respect to 1, what is 3 with respect to 2, and like that finally I have to reach n. So I have told capital N, so let me write. So it will be, the final one is hand, the hand is in joint n. So let me write it in that way. The final one is the joint n minus 1 transformation. I have to make it finally to reach the hand, and all of this will cancel out. So what is this one? Short form of this one is a1, the next one is a2, like that I will go all the way. Let me write a3 also, since I have written there, and finally I will get a hand. So this is the multiplication that I have to do. I will write an example also, just because we have done so much. It's not a very difficult thing, just look at this. We have to by heart this matrix so that I am able to write it. Suppose I have to write 2t3, so it's an example. And this is our step 3, so I will write step 3. So I have to write the example, so this one. So what is n plus 1 here? It is 3, so I will write a3. And wherever I am having in this equation n plus 1, which equation? The equation I am going to look from here. So they're all in n plus 1, I will represent it as 3. So it will be cos theta 3, sin theta 3, 0, 0, followed by the next is this, what do you say, column? So it is minus sin theta 3, cos alpha 3, cos theta 3, cos alpha 3, sin alpha 3, 0, like that I can continue and get. So always remember, if I have to find an, then I should know for an I should know how to, or what is the value of the four motions that I'm going to give, isn't it? That is theta n, I should know. So I will write it as n plus 1 so that I don't get everyone confused. So for theta n plus 1 I should know, sorry, a n plus 1 I should know theta n plus 1. Similarly, what is going to be the next translatory motion, dn plus 1, then what is a n plus 1, and um alpha n plus 1. So these four quantities I should always know for writing this matrix, otherwise I will not be able to write this matrix. And in the next sections of trying to look at the various example and applications of this DH method, what we will try to do is we will always try to find out what are these four values with respect to each and every frame. Thank you.